This is brought to you by the Alumni Association of PISJ-ES.
Hey guys, today we'll be learning how to use a Vernier caliper. Basically, why we use a Vernier caliper. Let me just write what is a Vernier caliper. Basically, we use a Vernier calipers to add another digit of accuracy to our measurements from a simple ruler. For example, this is a ruler. Here. This is the centimeter side of the ruler. This is 10. Then there are, for example, just take that as 10. These are the little marks here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 11. Now if I measure something from here, from this side, and it turns out to come here, as in this is the length, for example, or let's just say, yeah, this is the length of that thing from here to here. What is the measurement? What is the answer? If I ask you what is the length of this thing, you would say this is 10, this is 0.1, 0.2, 0.3, 0.4, and 0.5 centimeters. It starts from here and ends here, and each dot is a 0.1 centimeters. So what happens is that if it comes right here, you would be able to say that the length is 0.6 centimeters. What if it comes between the two of them? You can obviously tell me that it's a 0.55 centimeter, but, and for our purposes, as in kind of measurements we make, very casual ones, this is quite sufficient. But for the ones where accuracy is very important, for those kind of measurements, this is not marked as accurate. Since this is not measurable on a ruler, a second digit is not attainable on a ruler. You cannot get the second digit on a ruler because there is no mark here. You're just estimating. It might be 0.554, it might be 0.53, 0.56, anything, but you are just estimating it to be 0.55. So that is 0.5 and 0.6 is the most it can tell me about a reading, not the second digit. So we can say, here comes the word accuracy. I can say safely that the accuracy of a ruler is 0.1 centimeters, or as we've seen earlier, 1 millimeters. Because after the 0.1 reading, as in after the 0 point, the first digit in centimeters, this is the most it can tell me accurately. After, if I talk about the second digit, I cannot be sure whether the reading is right or not on a ruler. But for the very same reason we use the Vernier calipers, we want to add a second digit here, which is accurately measured. That is why the Vernier calipers are used. They are more accurate. Now, for a Vernier caliper, the accuracy is 0.01 centimeters or 0.1 millimeters. So this adds up. This gives me one more digit of accuracy to the readings that I took from the ruler. Now, how does a Vernier caliper look like? Let me show you. This is how a Vernier caliper looks like. you can see clearly from here. Sorry. These are, you might have seen this in your lab, in your physics lab. These are the external jaws of a vernier caliper, where you fix your object to be measured here. And the external jaws are used to measure the outside diameters. For example, the outside diameter of a ball, the length of an object, for example, length of a small cylinder. The outside diameters are used to measure, the outside jaws are used to measure that. But these ones, the jaws here, they're used to measure the inner dimensions. For example, the inside of a cylinder, or things like these. The screw clamp, whenever you put a thing here, any object here, and you bring this vernier scale close to it. This is a movable vernier scale here. This can move. This thing moves like this, here and there. So when you tighten it right here, you put a thing here, you tighten it right here, you clamp it with this thing, and you turn the screw here, which fixes the reading so that it does not move now, it tightens now. This is the main scale of the Vernier calipers. Right now it's calibrated in centimeters. You can see here, it's calibrated in centimeters. And this is the vernier scale, or the movable auxiliary scale. This can move. So there are two scales here. Okay. So, and this is the stem for measuring depths. For example, I can measure the depth of a cylinder. I can put this tip inside the cylinder and measure the distance from here to here using the same scale. But this is not of much use to us in our study, so we'll stick to the internal and external jaws. Okay, so now assume that you have fixed an object here. You have just fixed an object here and you have tightened the clamp. Now you are seeing something here on the scale. The most important thing is to learn how to read the scales. So we will move to the readings, taking the readings. In a Vernier calipers. Now let's see, there are two scales. The main scale and the vernier scale. The main scale readings are taken from the point where the zero mark of the vernier scale coincides with. If you're getting confused, then don't worry, I'll explain to you right now. Of vernier scale coincides. The point on the main scale this is the point on the main scale where the zero mark of the vernier scale coincides. For example, let's see here. Over here, this is the zero mark of the vernier scale. And this we'll have to see where it coincides with a reading on the main scale. This is the main scale and this is the vernier scale. So for the main scale reading, we'll see the zero here. This coincides with this reading. And this is 3.1 centimeters, since this is in centimeters. So our main scale reading in this case would be 3.1 centimeters. Okay, that is the easy part. You just check the zero on the vernier scale and you see which mark on the main scale it coincides with, and that is your main scale reading. This is easier. Now for the vernier scale reading, there are two readings. For the vernier scale reading, you will now have to observe both the points on the main scale and on the vernier scale. Okay, and you will have to check for 2 points that coincide with each other. 2 points on the same line, like this, on the main scale and the vernier. This is, for example, the main scale, and this is the vernier scale. They would be the readings would be coinciding like this. So you will just pick up that number. For example, this is the vernier scale, and this is the first reading, this is the second, third, fourth, fifth. The sixth reading perfectly coincides with a reading on the main scale. You don't need to worry about which reading it coincides with on the main scale, but all you have to think about is that it coincides with a reading on the vernier scale. Now, this is the reading that coincides with the vernier scale. What you do is you multiply it with the accuracy of the vernier scale. You take the sixth reading and multiply it with the accuracy of the vernier scale, which is in this case 0.01. This would become 0.06. Now this is your vernier scale reading. Add the two up. This would become 3.1 is the main scale reading and is the main scale reading, and 0.06 is the vernier scale reading. Your answer would be 3.16 centimeters. You can see you are adding one more digit of accuracy here, and you have calculated this accurately in this case. So you have added a second digit, a second decimal place with accuracy right here. Before, when we were measuring it with a ruler, we could only reach till this point and not this one. So we have added a second digit of accuracy. Now, for those who are confused in this right now, let me show you something. Here I have a vernier scale present. It's on a website. It's just a simple Java applet, so you can access this. It's easy. We will be using our concepts and applying to this vernier scale, vernier calipers. So let's see. Let me just randomly take a reading. Okay. Let's take this. This is our reading. Okay. So if you remember, the first thing that you do is you take the 0. You see where, for the main scale reading, you will have to first find the main scale and then the vernier scale. So for the main scale reading, you will check which point the vernier scale, the 0 mark of the vernier scale coincides with. This one. This is the movable vernier scale. It moves like this. And imagine this is the object here, and this is the fixed reading. We have turned the clamp here. This is the reading. So you can see the 0 mark coincides with this mark, as in it's a little more than this mark, but we will always use the one before. If it's in the center, we'll use this mark. So this is 1, 2, 3, 4, 5, 6, 7. This is 7 centimeters. So this is good. Okay, or this scale is in millimeters, so this should be 7 millimeters. Okay, this scale is in millimeters, I can see from here. So our main scale reading in this case would be 7 millimeters, our main scale reading. Now comes the vernier scale reading. The vernier scale reading, for the vernier scale reading, we'll have to carefully see which 2 points coincide on both the scales. So if you see this one doesn't coincide, these two aren't coinciding. Look at this carefully. This is not coinciding, this is not coinciding. No, 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 yes. This is coinciding. So you can see 9 is just coinciding with this one. So we won't say it's 9 millimeters. No. It is the 9th mark on the vernier scale. We'll say this is the 9th mark on the vernier scale. Now, since the reading is in millimeters, we will multiply this 9th mark with the accuracy of the Vernier calipers. The accuracy of the Vernier calipers is 0.01 centimeters or 0.1 millimeters. So right now, since we have taken the main scale reading in millimeters, we'll take the Vernier scale reading in millimeters as well, and we'll multiply it with this. So 9 times 0.1 millimeters would give you 0.9 millimeters. Now this is your main scale reading and this is your Vernier scale reading. Now all you have to do is to add Vernier scale plus main scale. So 7 plus 0.9, this will give you 7.9 millimeters. So I hope you guys understood this. If you haven't understood this as yet, we'll be doing some more examples of this in our next lectures. So stay tuned to it, and thanks for watching.